Chapter 5, Elementary Probability Theory, Section 5.3, Trees and Counting Techniques. Okay, let's see. Focus points of this particular section: organize outcomes in a sample space using tree diagrams. Compute number of ordered arrangements of outcomes using permutations. Compute number of non-ordered groupings of outcomes using combinations. Explain how counting techniques relate to probability in everyday life. So let's understand these three techniques of counting basically. Okay. When outcomes are equally likely, we compute the probability of an event by using the formula. Probability of event A is number of outcomes favorable to the event A over number of outcomes in the sample space. The probability formula requires that we be able to determine the number of outcomes in the sample space. In the problems we have done in previous sections, this task has not been difficult because the number of outcomes was small, or the sample space consisted of fairly straightforward events. For instance, rolling of dice, or drawing out marbles, or flipping a coin. Here the number of outcomes are small. The sample space was small, straightforward events, right? So let's see if things get complicated. The tools we present in this section will help you count the number of possible outcomes in larger sample spaces, or those formed by more complicated events. When an outcome of an experiment is composed of a series of events, the multiplication rule gives us the total number of outcomes. Here is the multiplication rule of counting. Consider the series of events E1 through EM, where N1 is the number of possible outcomes for event E1, N2 is the number of possible outcomes for event E2, and so on. So number of outcomes for event E1 is N1. All right. Number of outcomes for E2 is N2. Number of outcomes for EM is NM. Then the product N1 times N2 times all the way to NM gives the total number of possible outcomes for the series of events E1 followed by E2 up through event EM. Okay, let's look at an example. Jacqueline is in a nursing program and is required to take a course in psychology and one in physiology. Okay, A and P. First A here. Next semester, she wants to take Spanish too. All right. If there are two sections of psychology, two of physiology, A and B, and three in Spanish, how many different class schedules can Jacqueline choose from? Assume that the times of sections do not conflict. Okay. Creating a class schedule can be considered an experiment with a series of three events. There are two possible outcomes for psychology because there are two sections available for psychology. Two for A and P section and three for Spanish 2 section. So 2 for psychology times 2 for physiology and 3 for Spanish. So in all, when you multiply, you get 12 options, 12 possible schedules. Here is a way. A tree diagram gives a visual display of the total number of outcomes of an experiment consisting of a series of events. From a tree diagram, we can determine not only the total number of outcomes, but also the individual outcomes. For instance, here you are starting building your schedule. Psychology, you have two options, 1 and 2. Once you have chosen an option for psychology, there are two options for A and P section. For each A and B section you choose, there are three options of Spanish. So 111, 112, 113, these are all different schedules. Likewise, 121, 122, 123, these are different schedules. So notice how many do you have? 3 here, 3 here, 3 here, 3 here, 12 in all. 12 end branches. Okay, so a tree diagram is very nice way to explain what's going on. 2 for psychology, 2 for A and P, and 3 for Spanish. And that's what has happened here. All right. Okay. There are two branches from the start. These branches indicate the two possible choices for psychology sections. No matter which section of psychology Jacqueline chooses, she can choose from two available A and P sections. Therefore, we have two branches leading from each psychology branch. So, you are done with psychology, you are done with A and P. Now, after psychology and A and P sections are selected, there are three choices for Spanish too. That's why there are three branches from each A and P section. So, psychology, A and P, and Spanish. Okay. So the tree ends with a total of 12 branches. Number of end results tells us the number of possible schedules. The outcomes themselves can be listed from the tree by following each series. Okay. So 1, 1, 1, 1, 1, 2, 1, 1, 3. So these are all possible schedules. They have written them in a table form. Okay. The other 6 schedules can be listed similarly. So here are 6 of these: 111, 112, 113, 121, 123, 123, right? So the next one would be 211, 212, so on. So those are the next 6 schedules. In all, you have 12 such schedules. Okay. Let's come to factorial notation. Okay, this is an important notation. That symbol, exclamation mark, in mathematics it is called factorial. 0 factorial is defined to be 1. 1 factorial is defined to be 1. For any number, any whole number greater than 1, n factorial is, you multiply n minus 1, n minus 2 until 1. What does this mean? 10 factorial will be 10 times, 9 times, 8 times, all the way until 1. So it's a count down from your number until 1, and you multiply them all. All right. So let's come to this particular slide in our next video.